the conduction current. You know, as the magnet goes by, the magnet wants to couple to it, wants to turn the aluminum. So if you change the angle of the cone geometrically against the magnet, watch. It will change the speed.
You're just lifting it up.
Oh, yeah.
See?
Oh, I see what you're doing.
So if I change the angle more,
Okay, so this is
So it's not really touching it well.
So cool.
no, it's not touching it.
Steps now.
It's not touching it at all.
it's sort
Those
of
are
at
eddy
a phase
currents
where
in
you
the
change
aluminum,
That's,
right?
well, when the neomagnet goes by the aluminum, it makes a circulating current, and it couples, and it drags the aluminum along with it.
Same thing in an induction motor.
Yeah.
It's got that aluminum core with the rotating field around it and drags the aluminum around with it.
Science is science, guys. You're not going to change it.
That's the same if you drop a magnet through a
Yeah,
copper pipe,
exactly.
right? And it
Right.
slows it down when it goes
The
through.
currents are going to keep it
Yeah,
there.
yeah. Yeah, it does. It does, yeah.
See, so if you line it up where you change, as you change the angle, watch.
So the closer
Why
it
does
comes to
the
90.
coil split and one go on top and one go
Because
on the
it's
bottom?
a two-wound coil. You're seeing this phase and this phase and this phase and this phase.
How many, is that two different windings or
coil is
more? How many
Yeah.
windings are in there?
And where there's
It's
two
two
different
colors.
windings here, and there's two different windings here.
Yeah.
How do you get more than one phase out of only one transistor?
The transistor has nothing to do with the phase. It's just a switch.
Right?
Well, you have two.
Phase are the magnets that are changing in polarity as they go by the coils.
How do you wind the coils?
You have to put wood dowels, and you make the loops.
Would
See,
you
these
just
are
hammer
split.
nails into a board?
That's
and
what I
round?
did at
Yeah.
first.
And
Okay, and then how are
is
they
there
wound?
a certain size that you
How are
pick?
they wound?
Well, they're wound like this, and this is wound like this.
So is it?
What is the material on that ball?
Is it
No, it's carbon graphite.
are the two windings coming off wound together at the same time? They're not lit or anything
no,
like that.
no. This wire comes with the wires already together,
Oh, okay.
so they're bonded together.
All right.
This wire here is independent. There's two at one time. And notice there's a lot more here.
Do the number of turns on the coils matter much?
Yeah, they do.
Yeah.
There's 300 turns here, and there's 900 turns here.
So,
Same gauge wire. No, this
No,
is thinner.
this is smaller, and this is bigger.
it's like a 3-to-1 transfer.
Yeah, it is.
Yeah.
So that little guy in the middle, he repeats the basic transistor? This guy's
No,
on the
this little
collector?
guy here,
He's a collector.
is, see when the magnet, this is like a window. Here, let me put this on, and we'll go over here. Let me show you guys something. I didn't want to put it on the film because I'm not supposed to talk about it. I started to do it, and then I got wound up in something else.
Slide you back in. Now we're going to move in.
Let's go to the coil. If this is the coil, right? And this is space surrounding, nothing's coupling in space. Nothing at all. If things were coupling in space, if everything was coupling right now, you'd see electrical discharges everywhere. Every once in a while, when things get just right in the atmosphere and you get the charges right, you get lightning. Yeah. So space is whatever height we're at here, there's a voltage gradient, right? It's like 0 volts and 20 volts and 200 volts and 800 volts and 4,000 volts. Because that's the way it is, right? A coil in space has no meaning unless you can do something with it. Where does the high voltage come from the coil? Because it's just a piece of wire that's wound around here, right? Like this.
What's the movement of the...
First of all, let me ask you a question. Do you know what back EMF is?
Yeah,
What is it?
it's the induced EMF when
It's nothing.
the magnetic potential.
When the field is
EMF.
collapsing, it induces.
The environment around
If the battery, look, if the battery is 12 volts here, and this is 0 volts, the only back EMF that can come from this coil, this is your big mistake, is less than the 12 volts. That's not what gives you this. Think about that for a minute. Before you go nuts.
Yeah.
I'll tell you what. I wrote this paper for Edinburgh and they wouldn't publish it. They said we can't teach them that. We cannot teach them that. There's a DVD back there with me from one of the PhDs from Edinburgh. And we're writing the paper. Remember what I said. This right here is nothing more than an energy pump. Okay? You know what I mean by an energy pump? It's a pump. Creates an electromagnetic field that collapses, that compresses this material into this little blotch wall. And when the electricity goes away, what does this blotch wall do?
Expands.
Woof!
Yeah.
It goes beyond, and your voltage goes 300 volts.
Oh yeah.
Exactly the height of the atmosphere that the coil's at. Go check it out.
So if the coil is at a higher elevation, you'll get a higher.
You'll get a higher voltage. The gradient's different.
So, did you ever build these tall ones?
Absolutely. I moved to 2,300 feet to find out from sea level.
Oh, so you don't have to. It doesn't have to be really tall. You could
No.
go up at a higher location.
Yes, and you get a higher voltage.
Did it like blow things up when you did that?
No, you see, these things are in gradients, right?
It's
So say this is 500 feet, and you can get the gradient of this, which may only come to here.
And what is the number for the gradient? 150 volts per meter?
Yeah, something like that. It's close. It can be less, depending on what the coil is, how thick the wire is, what the inductance is. See, what I noticed was, doing this experiment, is charting this, I noticed that the altitude had a lot of difference to do with it. And what area you were in had a lot of difference to do with it.
Geographic location.
Yes.
And elevation.
Yeah. And the more that I wound the coil right, well, of course, the more I got. Because the higher it got, but the more voltage it took to push that blotch wall in. So what you're looking at is something like this. What you're looking at. That's what you're looking at. So what does that make up, guys?
Lotus. lotus petal.
Makes up a pattern in nature.
John, so what you're intimating also, let's say for example, I live in an area where there's still a lot of old copper in the ground and also a lot of quartz in the rock formations.
You go grab Peter Linderman,
Yeah.
and Peter Linderman will tell you we built identical machines. Mine worked, he went up north, his didn't work. Brought his machine back to my place, it worked.
Got it. Okay. So there is
Yeah, because your magnetic field is spinning. It's spinning one way on one side and the other way on the other side. And what you want to do, what you're thinking about doing here is you want to create an energy pump. You want to suck it in, compress it, and let it go. Same thing. I never found it. I tried it. Yeah. I got it to work every which way once I understood exactly what it was. I could build any one of them. No.
Which book or video has this in?
The one, I don't never put this in a video. I never put this in a video. I never showed anybody this because of what they said. They said, well,
Does it generate a magnetic impulse here?
what they told me was we could never teach this because then we wouldn't have any control on energy.
Who's they?
All the schools, everything, all the professors, everything. They would wreck the system.
So this is not explained anywhere.
When you say
No, not explained as a pump.
when you say Bloch law, what do you mean by that?
Watch.
Bloch.
Get on your phone and type it in the internet. Watch wall.
BLOCH.
Because as the magnetic field gets compressed on the copper adds its own magnetic field counter.
Cool.
The counter is making the opposite field. So
You're making this is
yeah, but that's what I mean.